So, from a man in a lab coat to a girl with a shitty robot. Been in charge of electrical engineering for quite a while and been struggling a little bit with renewing electrical engineering education. The picture of electrical engineering education a lot of people have is pictures like this. A wonderful picture of Nikola Tesla, 1901, sitting in his lab doing his experiments. 1901 was also the year when electrical engineering was founded at KTH, and the first professor was also installed at KTH 1901. And it's throughout the years, electrical engineering had a fantastic impact on society. We electrified society, we broadcast television, we arranged with communication, we created electrical vehicles, we did Internet of Things, we developed computers. A lot of examples on how we formed the society of the 1900s. But we also challenged a little bit to renew ourselves. We have had a big problem actually to recruit and in the Western world recruit students and attract students. It's also been a challenge that how to educate engineers has been challenged within the university world, and we were a little bit stuck with the image of men, teaching men. If we look a little bit to how education been developed, engineering educations in the early 1900s, they were all practice-based. So it was laborations and practice. And then what happened throughout the time was that science was coming in regulations, but then also more into how we were educating. So in the 60s we have a very good education with the base on science and practice. But then something happened where the practice went a little bit out of the window, and science became more and more dominant, to almost to an extreme in the late 1990s. That was actually the time when I was a student myself. And if I should describe my studies, it was theoretical courses. There was no projects. There were a few labs sitting with men doing elaborations. Some of my fellow students, they did their first teamwork when they had finished at KTH or in the student union. They did a first presentation when they did their thesis presentation at the end. And I even have friends that was so nervous that they actually almost went and vomit before they did this. So those were the engineers we sent out in the late 1990s. They all got jobs at big firms. They all, if you looked at electrical engineer, went to the big companies in Sweden. But then a lot happened very, very fast in Sweden. So the big companies did not employ the electrical engineers anymore. So they needed to find new places, and we needed to make sure that they were prepared for new types of jobs. KTH at the same time, they also realized and got feedback, and some other universities in Sweden, that this was not really what the industry wanted. So KTH was engaged together with MIT, Linköping and Chalmers in a concept called CDIO that was targeting to bring back science and practice together. CDIO wants to train engineering skills, which means teamwork, written communication, working in projects, oral communication, and those kind of what we call engineering skills. It also, with the acronym CDIO, says that an engineer that is graduated, they should know how to conceive requirements, how to design a solution for these requirements, how to implement the solution that they have done, that they have designed, and also how to operate it. And we need to make an education that captures all this. So that's been one of the KTH's guiding forces since the early 2000s. And we are working with it, we're getting better with it, and we are trying to get away from this man in the lab coat view. And we are getting closer. We are targeting right now. The next target is Vision 2027, and Gunnar Karlsson here will give a talk about that in an hour, so you can hear a little bit about what the next step will be in KTH Vision of 2027. So what is it that we want to target then? Well, we need to train students that is then adapted for the fast-moving tech industries, which means they're not going out for a research department that they will sit on for the rest of their lives. They still go, 50% of the electrical engineer students or more still go for research and development, but they don't typically end up in the large companies. So they get into companies and they move around, and they get a lot of challenges, jobs, and they need to also be very, very diverse in what they're doing. So how do we take on this challenge? Yeah. Then it comes in very interesting. It's a very, very interesting challenge to change an education that's been around for 100 years. The challenges that we had also meant that the theoretical base that was around when Tesla was there was physics. But the theoretical base today is not only physics. There's more and more a base in mathematics. And there's also more and more another kind of mathematics depending on if you go to wireless communication or if you go to computer engineering. So suddenly we need to broaden what we teach our students, and we need to get in all the engineering skills. And then with the resistance of faculty, don't want to change this great old program that we have had for so many years. We rebuilt the program where we did some small adjustments, and the great thing with the CDIO concept is that it allows making small adjustments. CDIO want you to build in all these things into the engineering courses, to build in all the steps and challenges in engineering courses, and don't do separate courses for teamwork, projects, etc. So we kept a couple of things. We redesigned the program. We have still a very, very strong base in mathematics. Physics was reduced. So most of the physics is actually now the applied physics that's within electrical engineering. The general physics went out or went to elective courses. Computer engineering grew bigger. And then the new things that we had to build in then to work with the CDIO concept was the project courses. So in each year we actually built in a project course. And here comes the thing with changing an old education. We implemented the first project course and then had to prove that it was working. And 8 years later, we implemented the second project course when we have proved that it worked to teach this early on. And now we actually got an approach where we have project courses basically every year, challenging the students. And I will come back to this a little later, but the purpose of these project courses is to give students a challenge that capture everything that they read in the year. So they have to do something practical with the knowledge they have in the first year. Second year project course ties together all the courses in the second year. The bachelor thesis project here ties together everything from the first 3 years. Then in KTH there is a master's program afterwards, and in there is typically can be a project course but not mandatory, but there is one big project at the end in the degree project. The other thing we worked with was trying to get seminar help with a seminar course, and the reason to implement the seminar course into the program was by the late 90s, early 2000. The idea of what electrical engineering was starting also to be very hard to communicate. In the old days, it was very easy to communicate what electrical engineering was because of what happened in society. But in the early 2000s, there were a lot of different electrical engineering-like programs. At KTH, we had microelectronics, we had IT, we implemented medical engineering as a separate program, and a little later we also got energy and environment. So it was getting harder and harder to communicate what is electrical engineering within all this. and that came out, especially if we look into this, I'm talking about the girl with a shitty robot. It was especially hard to communicate and get through to female candidates what this education was really all about. So we were struggling a lot with that. And that can be done in many ways. We decided to create a seminar course called Global Impact of Electrical Engineering. And Global Impact of Electrical Engineering is such a simple thing as a course that talks about the future challenges that electrical engineers will have to help for the future. So it's a seminar course. The students from the first 3 years, they sit together. They meet a researcher. So 50% of the faculty within electrical engineering are mentors, meeting students at least 4 times a year. And they sit down in a group and they discuss a subject. And these subjects, they roll with 3 years intervals. So this year we have the energy for the world is the subject that is talked about. So it's discussing then what is the energy need for the world, what is the future in energy system, how is fusion going to be developed, and all the challenges that electrical engineers will have to deal with in solving the energy problem for the world. Next year is going to be mobility. So mobility of information, things, and people. So we then talk about different kind of solutions to do this and the challenges in how electrical engineers will have to work with those solutions for the future of the people. And the last year we have the aging society and how electrical engineers comes in dealing with the problems of an aging society. And then we go back to the energy of the world. So this is typically things that we discuss in this course. We invite our researchers to give talks. So there's 2 talks. There are 4 talks every semester. And the students then make a reflection on it. And they think about how they're going to be able to contribute in this. And then they meet the faculty to discuss it. So it is perspective course, but they already early on in the education get to see what they're going to use the theories for and what the kind of future challenges we have. So that's one way to help students to understand and get an identity within electrical engineering again. So it's a thing that's been it's been fun. It's been motivating, and I actually think I can say that it's been motivating for faculty to start meeting the students early on. The other thing that we typically built a lot of was then these kind of project courses. We had one in every year, and in the first year, if we look at the first year again, that's the mathematics. It is the digital design, electric circuits, is programming, and it's computer engineering. And in the project course, the students get the challenge to build a shitty robot that solves a daily problem in someone's life. And they can invent whatever they want. The only requirement we have is that they use an Arduino. So we actually give them an Arduino in the beginning of the course, and that's what they have to do. They have a budget. The budget is their own, the hours that they get paid, and they have to make a profit, or we try to encourage them to make a profit to be more efficient than the credits we give them. So if they work faster, we still give them the credits that we have promised. The solutions can come up to a lot of different things. So this year we got a few things. Of course, they're engineering students, so we got a couple of beer machines that open beer bottles automatically. You just put the bottle in, and the machine takes care of everything, opening the bottle, pour it up to a glass, and fix everything. Yeah. So we got 3 fantastic solutions like that. We also got a couple of tea boilers, automatic tea boilers for you in the morning. You don't have to do anything. You just press the button, and then when you come out of the shower, the tea is ready for you to go. So those were a few of them. Another one we got that got a little bit looking at helping society is this fantastic equipment. It's a mailbox solution. You screw it onto an apartment door on the inside, and when someone drop in the mail, it's very hard for older people to bend down and pick up the mail. So there's an elevator. So here is a sensor feeling that you got mail, and then the elevator starts and it drives the mail up and it drops it off in a box here on a reasonable height, so you easily can get your mail. So you can put it on your door. It worked fantastically. And a lot of other things like paper pianos and so on. And we're going to show you a little bit of a video, because in the training of doing communication, we're forcing them to use different means to communicate. So they do poster presentations, they do oral presentations, they do reports, they do public, small kind of, what should we say, public advertisement conversation, reports, but they also make a YouTube video. And the whole thing with Shitty Robots is inspired by Simone Giertz, who has a Shitty Robot YouTube channel. So they had to follow her concept and make a YouTube video. So I'm going to show you a little bit of that.
I have always known that I'm not like the rest of my family. My home is not suited for me. Most features in our home require strange pause that I do not have. I would like to be able to start the tap by myself. It's really annoying that I have to yell for several minutes before anything happens. The water in the bowl smells weird. I don't dare to drink it. I have been scared of not getting enough water ever since my friend died from dehydration. There has to be a way for me to start the tap. Since my CATCRAN was installed, my life has been transformed. I no longer need help at all to drink water. I don't have to be afraid of dying from dehydration anymore. I should have contacted CATCRAN earlier.
So this is an example of typically what the student does in the first year. Second year project courses gets a little bit more advanced. So there we bring in the physics. And this year's challenge is they're going to send the electricity wireless for 10 centimeters, and they're going to boil water on the other side within 10 minutes. So they have to build a transmitter. They get 25 volts and 2 amperes, and they're going to design an equipment that can wireless transmit the energy and boil water on the other side. And they cannot use any commercial components. They can buy a copper wire, they can buy that kind of things, but they cannot buy anything pre-made. And then they go through the whole CDIO concept, which means they firstly they conceive what is a requirement, they write a specification with a promise what they're going to do, then design from the 25 volts 2 amperes to the effect that they need to boil water on the other side, all the steps. And when they get that approved, we let them go into lab and build it and try to build according to their own specifications. And then they need to operate it and demonstrate it to a very interested group of teachers trying to see if it works. Yeah. So that's typically what we do in the last year, in the second year, and then the thesis project ties things together. So we really try to go from this being alone in a lab looking at things to work together in a team, building sometimes really shitty things, but at least building and getting some dirt under your nails again, solutions for the future world. And we hope that this is the way that we are training engineers so that they can help taking care of energy problems, transportation problems, Internet of Things problem, and all the problems that we need to have a sustainable future. So thank you very much.